Hey everybody, welcome back. This is lesson 5 in our Unit 7 solutions, and today we're going to talk about concentration calculations. This is going to be a two-part video. So in part 1, we're going to cover molarity. So in the last video, we talked about the different types of solutions, and we talked about table G and how to use it, and how to read these different solubility curves. And like I had said before, today we're going to start with these concentration calculations focusing on molarity. So molarity, you might see the word mole. So before we get into that, we're going to do a quick mole mass conversion review and then jump into the molarity equation. So concentration, what is that? So let's start off with a joke and move forward. Okay, so before we kind of move on, let's cover a few ground rules. So, ground vocabulary, I guess. So first, concentration, again, is the measurement of the amount of solute that is dissolved in the given quantity of solvent. So just quick recap, solute gets dissolved and solvent does the dissolving. So if we were thinking about salt and water, we can say the salt is a solute and the water is your solvent. So that's concentration. If you have a concentrated solution, that means you have a large amount of solute. And if you have a dilute solution, you have a small amount of that solute. So think about it like very concentrated lemonade with a bunch of that lemonade powder. And if you have a very dilute lemonade, you have very little lemonade powder in there. Okay, so unit of concentration. Most of these formulas are on table T, so that last page of your reference table. So mass percent of solute, parts per million, and molarity. So all three of these formulas, or variations of them, are on table T. And like I said before, today we're going to focus on molarity. And there is a percent by volume one, which is very, very simple. Follows mass percent pretty similar, but slightly different. Anyway, that's part 2 of the video. So next video we'll cover those 3 things. But before we get into molarity, again, molarity kind of sounds like mole, and so we have to review mole mass conversions first. And so I'm going to make your life difficult, so we're going to give you the most complicated versions of these questions. Again, if you can do the more complicated ones, you can do the simpler ones. So my question for you is, how many moles are in 68 grams of copper 2 hydroxide? And that is the formula. So when we're doing conversions, we're going to use dimensional analysis. And so we're going to write down our given, which is 68 grams, put our given over 1. Now, we want grams to cancel, and we are looking for moles. And so when we did this, remember, we had 1 mole, and this number right there was the molar mass of whatever compound we were looking at. So in this case, we're looking at copper hydroxide. So we need the molar mass of CuOH2. And so I was mean and did not give that to you in the question. Let's go ahead and calculate that. We have CuOH2. So for copper, we have 1 of them. And if you look at the periodic table, the mass for copper is 64. And then if we look at oxygen, remember this 2 goes to both O and to H. So we have 2 O's. O is 16, according to the periodic table. You have our hydrogens. Again, we have 2 of those because that little subscript 2 means it's written as CuOH, OH. So that's easier to see. You could just have that parentheses and the little 2. And according to the periodic table, mass of hydrogen is 1. And so to get the entire compound, add all that stuff up together. So 1 times 64 is 64, 2 times 16 is 32, and 2 times 1 is 2. Add all up together, 64 plus 32 plus 2 gives you your molar mass. Remember, molar mass, the unit was grams per mole. So in 1 mole of copper hydroxide, it is 98 grams. So this 98 grams, our molar mass, gets put right into there. And again, our grams cancel out. We're looking for moles, and so we get 68 over 98. And when you plug it into a calculator, you get 0.69, and our unit is going to be moles. So just kind of a recap, if we're going from mass to moles, we are going to divide by molar mass. Again, sometimes they'll give you the molar mass so you don't have to calculate it, but I make you do the extra step because if you're comfortable with this, you can do the more complicated ones. So that was mass to mole. Let's do the opposite version, the other conversion. So in this question, how many grams are in 3.3 moles of potassium sulfide? So again, we're going to convert. We're going to use dimensional analysis. We're starting with 3.3 moles. That is our given. Put your given over 1. We're looking for grams. So we want moles to cancel. That goes on the bottom. Grams goes on top. Remember that 1 mole. And we have to find, right here, is the molar mass of K2S. And again, I did not give that to you in this question, so we have to calculate it. So for potassium, which is K, our formula says we have 2 of them. According to the periodic table, the mass of K is 39. And then if we have sulfur, which is S, our formula says we have 1 of them, and the periodic table says the mass is 32. So then when you go ahead and do some math, 2 times 39 is 78, plus 1 times 32 is 32. Add those two numbers together, you get 110 grams per mole. And so now we can use this number and plug it in right there, or 110 grams in 1 mole. And our moles cancel out. We're left with grams. And so it really comes down to 3.3 times 110, which is 363. Our unit is going to be grams, because that's the only thing that did not get canceled out. And again, if we're going to round to significant figures, or if this is a multiple choice question, you would see it as 360 grams. So hopefully that refresher helped you. If not, go check out Unit 4 videos. We covered this in a lot more detail. So now that we're semi caught up on mole conversions, let's jump into molarity. So molarity is a unit of concentration, and its unit is M. So if you see, let's say 5M, you would say a 5 molar solution. So we don't say molarity, we say molar, but the unit is molarity, and we need moles, but it's not moles. But again, it's abbreviated by that capital M. Remember, lowercase m is meters. So this comes right from table T, so that last page in your reference table. And so the formula for molarity is moles of solute over liters of entire solution. So how much stuff is being dissolved in the total volume of the entire solution. And so you can use the formula and plug it and manipulate it. Here's a nice little shortcut. Is the molarity triangle. It's kind of very similar to the density triangle. So whatever you're looking for, you just cover. So let's say I'm looking for molarity. Cover up M, it's moles over liters. If, let's say, clear these. If I'm looking for moles, it's molarity times liters. And if I was looking for liters, again, whatever you're looking for, you cover up, moles over molarity. And so remember, capital M is molarity, that's that concentration. N, lowercase n, is moles of solute. Whoever thought N for moles was a good idea, apparently in the world agreed with them. But N is moles. And then capital L is liters of solution, so that volume. Okay, so let's jump into 3 of these questions. And right off the bat, I'm going to tell you the first 2 are going to be a little bit challenging because I'm making you do an extra step or 2. And we'll kind of finish up with an easier one. Okay, so question number 1 says, what is the molarity of 1.5 liters of an aqueous solution that contains 52 grams of lithium fluoride, LiF? So we have a formula, we have a bunch of variables. So my first step is always to list out what we have. So we have N, which is moles, M, which is molarity, and L, which is liters. So we're given 1.5 liters, and we're given 52 grams. Now, the problem is none of these variables, so molarity has nothing to do with grams, moles isn't grams, but we have to use this grams to convert to moles and then use that number in our formula. So we have to find this using 52 grams of LiF. So this jumps back to what we did in the previous part of the video. Let's find and convert this to moles. So we have 52 grams, grams over 1. Grams on the bottom, moles on top, 1 mole. Again, this is the molar mass of LiF. And LiF, we have 1 Li, and Li has the mass of 7, plus 1 F, which has the mass of 19. 7 plus 19 is 26 grams per mole. So that goes there. Our units cancel out. We're left with moles. And so 52 over 26 gives you 2 moles. Or I should rather put 2.0 moles. Now, that's not our answer. We're just using this in here. So now our N is 2.5 moles. Again, we knew our volume. Now we just need to find the molarity. And so using our, let me grab a different color, molarity triangle, if we're looking for molarity, it's going to be moles over liters. And so you get 2.5 moles over 1.5 liters. And 2.5 divided by 2 point, hold on. This is 2.0, my bad, I can't transfer numbers. 2.0 moles divided by 1.5 liters. There we go. Everything matches up now. So 2 divided by 1.5 gives you 1.3. And moles divided by liters is moles divided by liters. Now, moles divided by liters is the same thing as molarity, or molar. So moles over liters, the unit, is the same thing as capital M. So you could see this written as 1.3 moles per liters, or 1.3 M. Both of those things are the same thing. Now, an easier question would give you 2 of these exactly and have you solve for the third one. I made it a little bit more challenging because I made you convert to moles first. This is by far the most complicated version of this question you will ever see because you have to convert from moles, but you also have to find the molar mass. So it is a very, very involved question. They won't all be like this. Okay, so let's do one more slightly difficult one, and then we'll end up with an easier one. Question 2 says, what is the total number of grams in HI in 0.500 liters of 1.00 molar HI? So again, we're going to list out our variables. We have N, we have M, we have L. And so we're given molarity, which is 1.00 M. We were given liters, 0.500 liters, and we're looking for moles. But the question says number of grams. So we have to find moles first, then convert to grams. So again, here is that extra step. So if we're going to solve for moles, we're going to cover up moles and its molarity times liters. So we get 1 molar, 1 M times 0.500 liters. That's N. And so 1 times 0.5 is 0.500 moles. Now, with the molarity, you can't exactly see how the units are canceling. So if we have moles over liters times liters, those liters cancel, leaving you with moles, and so that's why N is moles. Now again, this is not our final answer. We're just going to use that and plug it in here. So we get 0.5 mole. Now we have to use this number and convert it to grams of HI. So here is our, our given 0.500 moles over 1. We want moles to cancel, so it goes on the bottom, and we're looking for grams. 1 mole. Remember, when you're going from moles to grams, we're going to multiply by that molar mass. So that number is the molar mass of HI, or molar mass of high. And so HI, we have 1H and with the mass of 1, plus 1I with the mass of 127. 1 plus 127 is 128. So that number goes right there. So now everything's there. Moles cancel out, we're left with grams, and we get 0.500 times 128, which gives us 64. And the unit is grams because that's the only thing that is left. Again, most questions would have just asked you to stop at moles, but I'm making this a little bit more challenging, giving you that extra step, converting it to grams. So again, questions 1 and 2 are very, very involved. If you can do these and you're comfortable with these, that is totally fantastic because it does bring in a bunch of different questions. But let's look at the easier kind of spectrum of these questions, more of a straightforward question. So lastly, question 3 says how many total moles of potassium nitrate must be dissolved in water to make 1.5 liters of a 2 molar solution. So again, our first step should always be to list out our variables. So we're looking for moles. Remember, moles is N because that makes so much sense. 1.5 liters, that is our volume, or the L. And then 2.0 molar, so 2.0 M. And we're looking for moles. So again, if we're looking for moles, you can go ahead and cross that out. And so it's molarity times liters. And so moles is 2.5. I'm just going to write moles over liters like this so we can see the units. Moles over liters times 1.5 liters. Again, those liters cancel out. That's why we're left with moles. And 2.0 times 1.5 is 3. And again, our unit is moles. So that's the more straightforward question, giving you 2 out of the 3 variables and asking you to solve for the third. Again, the first 2 bring in a whole bunch of different concepts. It is kind of important that you see how all these things are related, but we'll work and kind of practice making sure you can make all these connections. So then that's pretty much it. Next video, we'll cover more concentration calculations, focusing on parts per million, mass percent, and percent volume. That is it. Have a wonderful day.